Good morning. So, for the chapter 3, part 2, instead of just making a key and putting it up on my website and you guys just go cram it and all that kind of stuff and then just regurgitate it, I thought what I'd do is I'd do an actual video lecture so that you can see how the problems are being solved, and I can do some narration with it, so perhaps it gives you some idea as to what the approaches might be. Okay, so I'm only going to do part 2 version A. Part 2 version B is very similar with the questions crumbled. So those people who do version B, you'll just have to figure out which question goes where. There is no redo or retake for part 1, the calculator based one. So I'm not going to do anything about that unless you have questions when I give you the test back. So let's start out with solving number 1. Okay, so in this question here, they're telling you that you want the answer in terms of log of A and log of B for solving for x. So this clearly implies that what you want to do is you want to take logs on both sides. So you go log A x minus 2 equals log B 2x plus 3. And then from some of the properties of logs, or one of the properties of logs, you know that when you have an exponent like this one here, okay, that has got to come down in front. So it really becomes x minus 2 log A equals 2x plus 3 log B. And so a few people could do this, but beyond this they kind of got stuck, which really surprised me, because all we are asking you to do is isolate or solve for x. You've done problems like this. You've done problems where, for example, you might have 2x plus 5 is equal to negative 3x plus 9. You know that you need to put the x's together. That's exactly what you need to do here. Same concept. Okay, the same concept. So sorry, this should have been log A here, my bad. And this should have been log B there. You got that. Okay, so let's take everything that has x's in it and keep that on one side. So this is log A. Then you've got 2x log B on the other side. We'll bring it over here and leave the other stuff that doesn't have x's on it together on the other side. So that's 2 log A. Now clearly what you need to do here is factor the x out. So you get x log A minus 2 log B is equal to 3 log B plus 2 log A. And then to solve for x, clearly what you need to do is you need to divide by this quantity here. Whoops. This quantity here. So then you get x is equal to 3 log B plus 2 log A over log A minus 2 log B. And that was your answer for that very first problem. The problem was worth 4 points. There are 2 points for the work and 2 points for the answer. And very often I'm very generous about giving points for work. You know, I don't necessarily even check to see if you're doing all these steps. I'm just being very generous there. But I do look at the answer very carefully and give points based on that. So that was number 1. Okay. Moving on to number 2, there was a very similar problem on your quiz on this one here. And what they want you to do is write it as a single log. In other words, your equation should have only one log. Your final answer rather should have only one log. There are people doing stuff like this. Okay, I mean that's complete nonsense. Okay, complete nonsense. So don't do stuff like that. You should know these things. Okay, these are problems that are done in Algebra 2. So what we need to do is first of all work on each one of the logs. So the first one turns out to be log x to the 1/4, and the 4 in the front, this guy here, comes up at the top. This guy becomes minus log y to the 1/2, and the next one becomes log z cubed, or z 1/3 to the 3/2. The 3/2 comes at the top like that. Okay, and then if you simplify this further, it becomes log x minus log y to the 1/2 plus log z to the 1/2. So you know that minuses mean division and pluses mean multiplication. So it all turns out to be log x z to the 1/2 over y to the 1/2. You could have left it like that, or you could even write it as log x square root of z over square root of y and leave the answer like that. This question was worth 4 points. Okay, 2 for work, 2 for answer. Okay. All right, problem number 1 and number 2 down. Number 3. Okay, number 3. Most people got this. This is straight out of the book. Straight out of the book. Practically nobody got the 1 point that I'd allocated for graphing this function here. I mean, to me, it is clear that I need to see what log to the base 3 of x is. Okay, so I need to graph that and then look at the transformations to answer my questions. I know I told you that I don't need any explanations, but it tells you quite clearly, use the graph of log y, of y equals log 3x. Okay, so I expect a graph there, okay, and I'd allocated a point for that. So that graph should look something like this. This is my y-axis, this is my x-axis, and you should know that this is the point 1, okay? So when you have to find the intercept for the log function, any log, log or ln or L3, log base 3 or whatever, the stuff you have in here has got to be equal to 1, because then your x value, your y value is equal to 0, right? Because log of 1 is 0. So you, and I think you need that concept later on in one of the other problems. So this is your graph for log to the base 3 of x. And then you need to really look at each one of the problems. So 53, it tells you it's a graph that's been moved up by 2 units. You don't need to explain this to me. You know that this is to be moved up by 2 units. So it goes like this. Okay? Well, which problem looks like it's going to be like that to close it? Clearly not that. Maybe this. Clearly not that, and clearly not that. So the answer is B here. Okay? So again, if you had this graph, and you didn't have to show me these translations or whatever, all I needed to see is a graph of log to the base 3x of this guy here. Okay, now it's 53. 54, okay, what it's saying is you're going to, let's take a look here. Let me get a different color here, blue. You're doing minus log 3x. In other words, you're going to flip the log 3x graph across the x-axis. So clearly it's going to become, let's use yet another color, black. It's going to come out like that. Okay. So 54 should have been, obviously this guy here, let me cancel, erase these things here. Okay. And 53 really looks like it's a C. So that's a C. That's this guy here. Okay. So that gets that one down. Okay. And then let's move on to 55, negative log 3x plus 2. So what you need to do is you need to worry about the x plus 2 first. So the x plus 2 makes the graph move left 2 units. So 1, 2. So it makes it move like that. Okay. And then the minus sign in front there, this minus sign in front makes it flip it. Okay, so it goes like that. Okay. So which graph is that going to be like? Clearly this one here. Okay, so that's B, C. So this was a C. This is a D, and therefore this leaves you with an A. Okay, so that's what the expectations for number 3 were. And this problem was worth 5 points, 1 each for the multiple choice answers, B, C, D, A, and 1 for the graph for log to the base 3 of x. You don't have to show me individual graphs of each function, but you need to show me graph of this guy here because it tells you use the graph. All right, moving on to number 4. Number 4. Is solve exactly, that means no decimal answers, okay, for 32 to the x squared plus x plus 1 and 128. So I hope you guys recognize that 32 is 2 to the 5 and 128 is 2 to the 7. So then this becomes 2 to the 5 x squared plus x plus 1 equals 2 to the 7, which means that this has got to be equal to that. Okay, pretty straightforward stuff. So 5x squared plus 5x plus 5 equals 7. And here really, it's truly amazing how some people either don't know how to or recognize that this is a quadratic equation or don't know how to solve this quadratic equation. Well, if this is going to be 5x squared plus 5x minus 2 equals 0. Okay, well, it's not factorable, and I've told you this before. It's not factorable because the discriminant is not a perfect square, b squared minus 4ac. So that's 25 plus 5 and 10 plus 40 is not a perfect square. Okay, it's equal to 65. That's not a perfect square. So you can't factor this. So, well, you know, quadratic formula. I mean, you learned this in 6th grade. So minus 5 plus or minus square root of b squared, which is all that stuff here that you already did, 65 over 10. And that's your answer. Okay. This problem was worth 4 points, 2 for work, okay, and 2 for the answer. All right. All right. Next one is problem number 5. The good thing about this one is that many people got this one correctly. So it tells you solve for x using change of base formula. So it tells you that. So what you want to do is you want to take the first log and change the base. Now to me, I'm kind of lazy like you guys are, and I like to use ln. So I'll do ln 6 over ln 4 for the first one. And then ln 2 over ln 6 for the next one. And then ln 4 over ln x for the next one. And these things are cancelling right there and there, there and there. So you get ln 2. ln 2 is equal to 2 ln x, which is ln x squared. So then these two quantities have to be equal. Okay? These two quantities have to be equal. So x squared equals 2. And then there are people who want the tendency of putting plus or minus. Yeah, it's true. It's okay. But can x be negative when it's the base of a log? You know that, okay? Cannot have a negative base there. So the answer should have been only root 2. Okay? And this problem was worth 4 points again. 2 for this answer and 2 for this work. Oops, where did this guy come from? Okay. So that's 5. Moving on to number 6. Let me pause here and take a sip of my tea. Resume. We are now on to problem number 6. And that's a solve a log equation. Okay. And again, this is based on properties of logs. Okay. So when you have a subtraction here, you know that it should be a division, right? X squared over 2x equals 2. And here's where people made a slight mistake. All they did was they started out canceling this x and this x. When you do that, you lose a potential solution, okay? Because you need to not quite sure why what's going on here. Okay, so don't cancel that out, okay? So then you get log base 3 of x squared over 2x equals 2, which means that 3 squared, which is 9, is equal to x squared over 2x, which means that x squared minus 18x equals 0. Factor is equal to 0, so x equals 0, x equals 18. This is a valid solution. This is extraneous because you cannot have a negative number in 0 in there, or there for that matter. So then this you have to stipulate is extraneous. Okay, so this question was worth 4 points as well. 2 for these answers, 1 for that, 1 for that, and 2 for the work. Okay. All right, number 7. Okay, number 7 was really a problem that we've done before in a slight disguise, okay? It's the interval notation kind of stuff, your number line analysis. The first question is asking you for the domain, okay? Is the domain. What's the domain? Well, for log, ln, or whatever, you know that the domain has to be such that this is greater than 0. 3x minus 2 over x plus 1 is greater than 0. How many times have you seen problems like this where you've got rational inequality and you do the number line stuff? You find the critical numbers, okay? Critical numbers are the zeros of the top, so x equals 2/3, and the zeros of the bottom, x equals minus 1. And then you go do your number line business. Okay, so here's 0, here's minus 1, here's 2/3, and you do your testing of numbers, okay? We've done this before. So then you say, let's say you test the number -2, you put it in here, and you know that the top is negative, the bottom is negative, and clearly that's greater than 0. And so you squiggle, 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 hole. Then you choose another number like 0 and test that inequality out. So you get negative at the top, positive at the bottom. There's no way this is going to be greater than 0, so you don't squiggle, 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 squiggle. And then you come out here and you test yet another number, like maybe 1. Okay, you put a 1 in there, you have a plus at the top, a plus at the bottom, greater than 0. Sure enough, it's greater than 0. Open circle, because this is strict inequality. Squiggle, 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 squiggle. So your domain is going to be minus infinity to minus 1, union 2/3 to infinity. That's your domain. 2 points for that. Okay, I'll go through the points in a minute. Okay, so taking care of domain. Range, you should know that ln or log or whatever go from minus infinity to infinity. Okay, there's nothing constraining that. So the range should be minus infinity to infinity. Okay, y-intercept. Y-intercepts happen when x is 0. Okay, when x is 0. So when you put x equals 0, you get ln of -2 over 1. Well, you can't have an ln of a negative number, so there are no y-intercepts. Okay, and now I'm going to be working like you, where my work spread all over the place. But please try not to do that. If you look at my key, and you should have seen my key many times, it's all organized. It's not all over the place. It's flowing typically from top to bottom. Okay, here I'm kind of restricted by space, so I'm going to go do the x-intercept. So again, I think we did this earlier. The x-intercept is obtained when this quantity is equal to 1, because then ln of 1 is 0, which means y is 0. So what you do is I'm going to use a different color here. Let's go do black. And so I have 3x minus 2 is equal to x plus 1 equals 1. 3x minus 2 equals x plus 1. And that gives me 2x is equal to 3. So x equals 3 over 2. So the x-intercept is 3 over 2, comma 0. All right? So what have we taken care of? We've got the domain done, the range done, the x-intercept done, the y-intercept done, and now all I need is asymptotes. So you should know that your asymptotes, let me erase some of the stuff here, for ln or log functions are vertical asymptotes. There are no horizontal asymptotes. Exponential functions have horizontal asymptotes, okay? And so if you look at this, the asymptotes happen when either this is 0, so that means x is equal to 2/3, okay? Or when this is 0, because then you get an undefined quantity, and an ln of undefined quantity is going to be undefined, so or x equals minus 1. So these are your vertical asymptotes, okay? This question was worth 10 points, okay? 2 for the domain, 1 for the range, I believe. 1 for the range, and these had to be all in interval notation. That's the standard that we work on, and you know that. 1 for the intercept, 1 for the y-intercept, 2 for the asymptotes, and 2 for that number line business that we did. So that's 2 into 4, 5, 6, 7, 9, and then there's still one more somewhere for the x-intercept, and then 1 for the y-intercept. So there should be 10 points for that problem. Okay? All right. Now for the bonus question. Again, this is straight out of the book. I mean, these are theorems, and you know how fond I am of theorems. You should know these theorems. You've done, particularly those guys who did honors geometry, you have done hundreds of theorems. And maybe you didn't remember all of them by word, but at least you understood the concept and all that stuff. In this book here so far, we've done maybe 3 theorems or 4 theorems. And surely you should know those things. Just like you know all the facts in biology or anatomy or APUSH or whatever those classes you take, where you got to cram the hell out of everything. Well, think about theorems, okay? They are important. They are foundational. They have created math, okay? So the remainder theorem states that if a polynomial, and that's crucially, we're only talking about polynomial, if a polynomial is divided by x minus k, okay, x minus k, let me write this nicely, just not nice, it's a theorem, we've got to be very pretty about this, x minus k, then the remainder is f of k. Now some people started talking about synthetic division and all that stuff. Synthetic division is not part of the theorem. Synthetic division is the process by which you get the remainder. So I didn't want to read anything about synthetic division or anything like that. Then after that, all you have to do is actually do the syndiv. So let's go do the syndiv. We've got 2 minus 3, 2 minus 1, 1, 2. And we are doing a minus 4 here. And then you do your syndiv. So that's 2, a minus 8, a minus 11, a 44, a 46, a negative 184, negative 185, and then times a negative 4, that gives me a 740, and that gives me a 741, and this guy gives me a negative 2964, and this guy gives me 2962. So then f of minus 4 is equal to minus 2962. That's the way you need to present the answer. And you can always check by putting in negative 4 in here for x and check that you get the same answer. These are your no smoking tests, okay? So there was plus 5 points for this extra credit problem, which I claim was probably the simplest thing ever, because it's a theorem that you should know. I mean, come on, you've done 3 theorems, okay? You should know these theorems, okay? Well, so much for yelling. Hopefully you guys are going to watch this video, learn how to do these problems, and we do it over again. All right.